Imagine a high-definition video camera that records every second of your day. It captures the colors, the sounds, the emotions, and the faces around you. Now, imagine someone sneaks in and permanently deletes the first 3 to 4 years of that footage. This is not a hypothetical scenario, it is your own life. Every human who has ever lived has experienced infantile amnesia, the complete and permanent loss of our earliest memories. Why does the brain erase its own history? Why can we not recall learning our first words, taking our first steps, or the faces of the people who held us? The answer is not that we were too young to remember, it is far more disturbing. Your brain actively erased your baby self. For centuries, science assumed babies simply lacked the hardware to form memories. We believed infants were passive observers with blank minds. But in the late 20th century, a psychologist named Carolyn Rovi Collier shattered this assumption. She designed a simple but ingenious experiment. She tied a ribbon from a baby's ankle to an overhead mobile hanging above their crib. The infants quickly learned that kicking their leg made the colorful mobile spin. When brought back to the crib days later, even the youngest infants immediately started kicking, proving they remembered the connection. They had formed a robust, associative memory. Babies are not blank slates. They are actively recording everything, which makes their sudden, total memory erasure even more mysterious. If babies can form memories, where do they go? The answer lies inside the hippocampus, the brain's master recording device for episodic memory. In adults, the hippocampus is relatively stable, allowing us to store memories for decades. But in infants, the hippocampus is a chaotic construction zone. It is experiencing a massive explosion of neurogenesis, the rapid birth of brand new brain cells. In 2014, neuroscientists Paul Franklin and Sheena Jocelyn at the University of Toronto investigated this phenomenon. They discovered that this rapid influx of new neurons, which seems like a good thing, actually destabilizes the brain's existing memory circuits. The very growth of the baby brain is what destroys its past. To visualize this, imagine a quiet forest with a single clear walking path. That path is a memory. If you walk it regularly, it stays clear. But now, imagine someone suddenly plants thousands of new trees directly across that path. The original trail is completely disrupted, covered, and lost. This is what neurogenesis does to the infant brain. As millions of new neurons integrate into the hippocampus, they remodel the existing connections. They overwrite the fragile pathways that recorded your first steps and your first toys. The infant brain prioritizes growth and learning capacity over long-term storage. To keep building new roads for the future, it must pave over the old ones. But cell growth is only part of the mystery. Another barrier is language. Adults think and retrieve memories using words. Babies, however, encode the world non-verbally. In 2002, psychologists Gabrielle Simcock and Harlene Hayne demonstrated this with a famous experiment called the magic shrinking machine. They had toddlers watch a toy get shrunk inside a colorful box. A year later, they tested the children's memory of the event. They discovered a strict barrier. The children could only describe the shrinking machine using words that were already in their vocabulary at the time of the original experience. Because we cannot translate our pre-verbal baby memories into our adult language-based minds, they remain locked in a vault we no longer have the key to. There is a third, even deeper psychological reason for the wipe. To have an autobiographical memory, you first need a self to whom the memory belongs. Psychologists Mark Howe and Mary Courage argued that episodic memories must be anchored to a cognitive self. But babies do not have a concept of themselves as separate individuals. This is tested using the mirror self-recognition test, or the rouge test. Researchers place a small red dot of rouge on a baby's nose and place them in front of a mirror. Before 18 months, babies reach out to touch the mirror image, thinking it is another child. Only after this age do they touch their own nose, realizing the reflection is themselves. Without this cognitive self, there is no narrator. While the mind is developing its sense of self, structural changes are also reshaping the physical brain. Key areas responsible for organizing and retrieving memories, like the prefrontal cortex and the dentate gyrus of the hippocampus, are highly immature at birth. They continue to develop throughout early childhood. During this time, the brain undergoes a process called synaptic pruning. It is a biological weeding system. The brain examines its massive network of connections and aggressively clips away the weak, underused pathways while strengthening the active ones. This pruning makes the brain far more efficient, but it also sweeps away the fragile early connections that held the details of your infancy. The physical canvas is being constantly scraped clean to make room for refinement. This constant erasure seems like a biological flaw, but evolution rarely makes mistakes of this scale. Neuroscientists believe infantile amnesia is actually a critical survival shield. Imagine if you could remember every single sensory detail of your birth. The physical trauma, the cold air, the sudden bright lights, and the pain of teething or learning to walk. If our infant brains stored these traumatic physical struggles as permanent episodic memories, we would grow up locked in chronic fear and anxiety. By wiping the slate clean, evolution protects us from the trauma of early survival. It ensures that we enter the complex world with a flexible, open mind, unburdened by the painful friction of our biological beginnings. But the erasure is not absolute. While your episodic memory, the specific details of what happened, is wiped, your implicit memory survives. Implicit memory governs emotions, motor skills, and core behavioral patterns. It is written in the brain's amygdala and cerebellum, which mature much faster than the hippocampus. This means that although you cannot remember the face of the parent who cradled you, or the sound of the lullaby they sang, the feelings of safety, warmth, and trust were permanently carved into your neural pathways. Your baby memories are not entirely gone. They have simply transitioned from stories you can tell into the very structure of your personality. You are the living archive of what you forgot. In the end, infantile amnesia is the price we pay for becoming human. We must sacrifice our early memories so that our brains can build the capacity to think, speak, and adapt to a complex world. The child you once were had to fade so that the adult you are today could exist. Your earliest years are not lost. They are the unseen foundation upon which your entire life is built. If you want to understand the unseen mechanics of human nature, subscribe. We decode psychological loops every week. Tell us in the comments, what is the single earliest memory you can still retrieve? Does it feel like a real memory or just a story you were told?